The NIST Framework for Improving Critical Infrastructure Cybersecurity. In audiobook format. Please like and subscribe for more content. This is version 1.1. From National Institute of Standards and Technology. The Executive Summary. The United States depends on the reliable functioning of critical infrastructure. Cybersecurity threats exploit the increased complexity and connectivity of critical infrastructure systems, placing the nation's security, economy, and public safety and health at risk. Similar to financial and reputational risks, cybersecurity risk affects a company's bottom line. It can drive up costs and affect revenue. It can harm an organization's ability to innovate and to gain and maintain customers. Cybersecurity can be an important and amplifying component of an organization's overall risk management. To better address these risks, the Cybersecurity Enhancement Act of 20141, CEA, updated the role of the National Institute of Standards and Technology, NIST, to include identifying and developing cybersecurity risk frameworks for voluntary use by critical infrastructure owners and operators. Through CEA, NIST must identify a prioritized, flexible, repeatable, performance-based, and cost-effective approach, including information security measures and controls that may be voluntarily adopted by owners and operators of critical infrastructure to help them identify, assess, and manage cyber risks. This formalized NIST's previous work developing Framework version 1.0 under Executive Order, EO 13636, Improving Critical Infrastructure Cybersecurity, February 2013, and provided guidance for future framework evolution. The framework that was developed under EO 13636, and continues to evolve according to CEA, uses a common language to address and manage cybersecurity risk in a cost-effective way based on business and organizational needs without placing additional regulatory requirements on businesses. The framework focuses on using business drivers to guide cybersecurity activities and considering cybersecurity risks as part of the organization's risk management processes. The framework consists of three parts: the framework core, the implementation tiers, and the framework profiles. The framework core is a set of cybersecurity activities, outcomes, and informative references that are common across sectors and critical infrastructure. Elements of the core provide detailed guidance for developing individual organizational profiles. Through use of profiles, the framework will help an organization to align and prioritize its cybersecurity activities with its business/mission requirements, risk tolerances, and resources. The tiers provide a mechanism for organizations to view and understand the characteristics of their approach to managing cybersecurity risk, which will help in prioritizing and achieving cybersecurity objectives. While this document was developed to improve cybersecurity risk management in critical infrastructure, the framework can be used by organizations in any sector or community. The framework enables organizations, regardless of size, degree of cybersecurity risk, or cybersecurity sophistication, to apply the principles and best practices of risk management to improving security and resilience. The framework provides a common organizing structure for multiple approaches to cybersecurity by assembling standards, guidelines, and practices that are working effectively today. Moreover, because it references globally recognized standards for cybersecurity, the framework can serve as a model for international cooperation on strengthening cybersecurity in critical infrastructure as well as other sectors and communities. The framework offers a flexible way to address cybersecurity, including cybersecurity's effect on physical, cyber, and people dimensions. It is applicable to organizations relying on technology, whether their cybersecurity focus is primarily on information technology, IT, industrial control systems, ICS, cyber physical systems, CPS, or connected devices more generally, including the Internet of Things, IoT. The framework can assist organizations in addressing cybersecurity as it affects the privacy of customers, employees, and other parties. Additionally, the framework's outcomes serve as targets for workforce development and evolution activities. The framework is not a one-size-fits-all approach to managing cybersecurity risk for critical infrastructure. Organizations will continue to have unique risks, different threats, different vulnerabilities, different risk tolerances. They also will vary in how they customize practices described in the framework. Organizations can determine activities that are important to critical service delivery and can prioritize investments to maximize the impact of each dollar spent. Ultimately, the framework is aimed at reducing and better managing cybersecurity risks. To account for the unique cybersecurity needs of organizations, there are a wide variety of ways to use the framework. The decision about how to apply it is left to the implementing organization. For example, one organization may choose to use the framework implementation tiers to articulate envisioned risk management practices. Another organization may use the framework's 5 functions to analyze its entire risk management portfolio. That analysis may or may not rely on more detailed companion guidance, such as controls catalogs. There sometimes is discussion about compliance with the framework, and the framework has utility as a structure and language for organizing and expressing compliance with an organization's own cybersecurity requirements. Nevertheless, the variety of ways in which the framework can be used by an organization means that phrases like compliance with the framework can be confusing and mean something very different to various stakeholders. The framework is a living document and will continue to be updated and improved as industry provides feedback on implementation. NIST will continue coordinating with the private sector and government agencies at all levels. As the framework is put into greater practice, additional lessons learned will be integrated into future versions. This will ensure the framework is meeting the needs of critical infrastructure owners and operators in a dynamic and challenging environment of new threats, risks, and solutions. Expanded and more effective use and sharing of best practices of this voluntary framework are the next steps to improve the cybersecurity of our nation's critical infrastructure, providing evolving guidance for individual organizations while increasing the cybersecurity posture of the nation's critical infrastructure and the broader economy and society. Section 1.0 Framework Introduction. The United States depends on the reliable functioning of its critical infrastructure. Cybersecurity threats exploit the increased complexity and connectivity of critical infrastructure systems, placing the nation's security, economy, and public safety and health at risk. Similar to financial and reputational risks, cybersecurity risk affects a company's bottom line. It can drive up costs and affect revenue. It can harm an organization's ability to innovate and to gain and maintain customers. Cybersecurity can be an important and amplifying component of an organization's overall risk management. To strengthen the resilience of this infrastructure, the Cybersecurity Enhancement Act of 20142, CEA, updated the role of the National Institute of Standards and Technology, NIST, to facilitate and support the development of cybersecurity risk frameworks. Through CEA, NIST must identify a prioritized, flexible, repeatable, performance-based, and cost-effective approach, including information security measures and controls that may be voluntarily adopted by owners and operators of critical infrastructure to help them identify, assess, and manage cyber risks. This formalized NIST's previous work developing Framework version 1.0 under Executive Order 13636, Improving Critical Infrastructure Cybersecurity, issued in February 20133, and provided guidance for future framework evolution. Critical infrastructure is defined in the U.S. Patriot Act of 2015 as systems and assets, whether physical or virtual, so vital to the United States that the incapacity or destruction of such systems and assets would have a debilitating impact on security, national economic security, national public health or safety, or any combination of those matters. Due to the increasing pressures from external and internal threats, organizations responsible for critical infrastructure need to have a consistent and iterative approach to identifying, assessing, and managing cybersecurity risk. This approach is necessary regardless of an organization's size, threat exposure, or cybersecurity sophistication today. The critical infrastructure community includes public and private owners and operators, and other entities with a role in securing the nation's infrastructure. Members of each critical infrastructure sector perform functions that are supported by the broad category of technology, including information technology, IT, industrial control systems, ICS, cyber physical systems, CPS, and connected devices more generally, including the Internet of Things, IoT. This reliance on technology, communication, and interconnectivity has changed and expanded the potential vulnerabilities and increased potential risk to operations. For example, as technology and the data it produces and processes are increasingly used to deliver critical services and support business/mission decisions, the potential impacts of a cybersecurity incident on an organization, the health and safety of individuals, the environment, communities, and the broader economy and society should be considered. To manage cybersecurity risks, a clear understanding of the organization's business drivers and security considerations specific to its use of technology is required. Because each organization's risks, priorities, and systems are unique, the tools and methods used to achieve the outcomes described by the framework will vary. Recognizing the role that the protection of privacy and civil liberties plays in creating greater public trust, the framework includes a methodology to protect individual privacy and civil liberties when critical infrastructure organizations conduct cybersecurity activities. Many organizations already have processes for addressing privacy and civil liberties. The methodology is designed to complement such processes and provide guidance to facilitate privacy risk management consistent with an organization's approach to cybersecurity risk management. Integrating privacy and cybersecurity can benefit organizations by increasing customer confidence, enabling more standardized sharing of information, and simplifying operations across legal regimes. The framework remains effective and supports technical innovation because it is technology neutral, while also referencing a variety of existing standards, guidelines, and practices that evolve with technology. By relying on those global standards, guidelines, and practices developed, managed, and updated by industry, the tools and methods available to achieve the framework outcomes will scale across borders, acknowledge the global nature of cybersecurity risks, and evolve with technological advances and business requirements. The use of existing and emerging standards will enable economies of scale and drive the development of effective products, services, and practices that meet identified market needs. Market competition also promotes faster diffusion of these technologies and practices and realization of many benefits by the stakeholders in these sectors. Building from those standards, guidelines, and practices, the framework provides a common taxonomy and mechanism for organizations to 1. Describe their current cybersecurity posture. 2. Describe their target state for cybersecurity. 3. Identify and prioritize opportunities for improvement within the context of a continuous and repeatable process. 4. Assess progress toward the target state. 5. Communicate among internal and external stakeholders about cybersecurity risk. The framework is not a one-size-fits-all approach to managing cybersecurity risk for critical infrastructure. Organizations will continue to have unique risks, different threats, different vulnerabilities, different risk tolerances. They also will vary in how they customize practices described in the framework. Organizations can determine activities that are important to critical service delivery and can prioritize investments to maximize the impact of each dollar spent. Ultimately, the framework is aimed at reducing and better managing cybersecurity risks. To account for the unique cybersecurity needs of organizations, there are a wide variety of ways to use the framework. The decision about how to apply it is left to the implementing organization. For example, one organization may choose to use the framework implementation tiers to articulate envisioned risk management practices. Another organization may use the framework's 5 functions to analyze its entire risk management portfolio. That analysis may or may not rely on more detailed companion guidance, such as controls catalogs. There sometimes is discussion about compliance with the framework, and the framework has utility as a structure and language for organizing and expressing compliance with an organization's own cybersecurity requirements. Nevertheless, the variety of ways in which the framework can be used by an organization means that phrases like compliance with the framework can be confusing and mean something very different to various stakeholders. The framework complements, and does not replace, an organization's risk management process and cybersecurity program. The organization can use its current processes and leverage the framework to identify opportunities to strengthen and communicate its management of cybersecurity risk while aligning with industry practices. Alternatively, an organization without an existing cybersecurity program can use the framework as a reference to establish one. While the framework has been developed to improve cybersecurity risk management as it relates to critical infrastructure, it can be used by organizations in any sector of the economy or society. It is intended to be useful to companies, government agencies, and not-for-profit organizations regardless of their focus or size. The common taxonomy of standards, guidelines, and practices that it provides also is not country-specific. Organizations outside the United States may also use the framework to strengthen their own cybersecurity efforts, and the framework can contribute to developing a common language for international cooperation on critical infrastructure cybersecurity. Section 1.1. Overview of the framework. The framework is a risk-based approach to managing cybersecurity risk, and is composed of 3 parts: the framework core, the framework implementation tiers, and the framework profiles. Each framework component reinforces the connection between business/mission drivers and cybersecurity activities. These components are explained below. The framework core is a set of cybersecurity activities, desired outcomes, and applicable references that are common across critical infrastructure sectors. The core presents industry standards, guidelines, and practices in a manner that allows for communication of cybersecurity activities and outcomes across the organization from the executive level to the implementation/operations level. The framework core consists of 5 concurrent and continuous functions: identify, protect, detect, respond, recover. When considered together, these functions provide a high-level, strategic view of the life cycle of an organization's management of cybersecurity risk. The framework core then identifies underlying key categories and subcategories, which are discrete outcomes, for each function, and matches them with example informative references such as existing standards, guidelines, and practices for each subcategory. Framework implementation tiers. Tiers provide context on how an organization views cybersecurity risk and the processes in place to manage that risk. Tiers describe the degree to which an organization's cybersecurity risk management practices exhibit the characteristics defined in the framework, for example, risk and threat aware, repeatable, and adaptive. The tiers characterize an organization's practices over a range, from partial, Tier 1, to adaptive, Tier 4. These tiers reflect a progression from informal, reactive responses to approaches that are agile and risk-informed. During the tier selection process, an organization should consider its current risk management practices, threat environment, legal and regulatory requirements, business/mission objectives, and organizational constraints. A framework profile represents the outcomes based on business needs that an organization has selected from the framework categories and subcategories. The profile can be characterized as the alignment of standards, guidelines, and practices to the framework core in a particular implementation scenario. Profiles can be used to identify opportunities for improving cybersecurity posture by comparing a current profile, the as-is state, with a target profile, the to-be state. To develop a profile, an organization can review all of the categories and subcategories and, based on business/mission drivers and a risk assessment, determine which are most important. It can add categories and subcategories as needed to address the organization's risks. The current profile can then be used to support prioritization and measurement of progress toward the target profile, while factoring in other business needs including cost-effectiveness and innovation. Profiles can be used to conduct self-assessments and communicate within an organization or between organizations. Section 1.2. Risk Management and the Cybersecurity Framework. Risk management is the ongoing process of identifying, assessing, and responding to risk. To manage risk, organizations should understand the likelihood that an event will occur and the potential resulting impacts. With this information, organizations can determine the acceptable level of risk for achieving their organizational objectives and can express this as their risk tolerance. With an understanding of risk tolerance, organizations can prioritize cybersecurity activities, enabling organizations to make informed decisions about cybersecurity expenditures. Implementation of risk management programs offers organizations the ability to quantify and communicate adjustments to their cybersecurity programs. Organizations may choose to handle risk in different ways, including mitigating the risk, transferring the risk, avoiding the risk, or accepting the risk, depending on the potential impact of the delivery of critical services. The framework uses risk management processes to enable organizations to inform and prioritize decisions regarding cybersecurity. It supports recurring risk assessments and validation of business drivers to help organizations select target states for cybersecurity activities that reflect desired outcomes. Thus, the framework gives organizations the ability to dynamically select and direct improvement in cybersecurity risk management for the IT and ICS environments. The framework is adaptive to provide a flexible and risk-based implementation that can be used with a broad array of cybersecurity risk management processes. Examples of cybersecurity risk management processes include International Organization for Standardization, ISO. Section 1.3. Document Overview. The remainder of this document contains the following sections and appendices. Section 2 describes the framework components, the framework core, the tiers, and the profiles. Section 3 presents examples of how the framework can be used. Section 4 describes how to use the framework for self-assessing and demonstrating cybersecurity through measurements. Section 2.0. Framework Basics. The framework provides a common language for understanding, managing, and expressing cybersecurity risk to internal and external stakeholders. It can be used to help identify and prioritize actions for reducing cybersecurity risk, and it is a tool for aligning policy, business, and technological approaches to managing that risk. It can be used to manage cybersecurity risk across entire organizations, or it can be focused on the delivery of critical services within an organization. Different types of entities, including sector coordinating structures, associations, and organizations, can use the framework for different purposes, including the creation of common profiles. Section 2.1. Framework Core. The Framework Core provides a set of activities to achieve specific cybersecurity outcomes, and references examples of guidance to achieve those outcomes. The Core is not a checklist of actions to perform. It presents key cybersecurity outcomes identified by stakeholders as helpful in managing cybersecurity risk. The Core comprises 4 elements: functions, categories, subcategories, and informative references. The framework core elements work together as follows. Functions organize basic cybersecurity activities at their highest level. These functions are identify, protect, detect, respond, and recover. They aid an organization in expressing its management of cybersecurity risk by organizing information, enabling risk management decisions, addressing threats, and improving by learning from previous activities. The functions also align with existing methodologies for incident management and help show the impact of investments in cybersecurity. For example, investments in planning and exercises support timely response and recovery actions, resulting in reduced impact of the delivery of services. Categories are the subdivisions of a function into groups of cybersecurity outcomes closely tied to programmatic needs and particular activities. Examples of categories include asset management, identity management and access control, and detection processes. Subcategories further divide a category into specific outcomes of technical and/or management activities. They provide a set of results that, while not exhaustive, help support achievement of the outcomes in each category. Examples of subcategories include external information systems are cataloged, data at rest is protected, and notifications from detection systems are investigated. Informative references are specific sections of standards, guidelines, and practices common among critical infrastructure sectors that illustrate a method to achieve the outcomes associated with each subcategory. The informative references presented in the framework core are illustrative and not exhaustive. They are based upon cross-sector guidance most frequently referenced during the framework development process. The 5 framework core functions are defined below. These functions are not intended to form a serial path or lead to a static desired end state. Rather, the functions should be performed concurrently and continuously to form an operational culture that addresses the dynamic cybersecurity risk. See Appendix A for the complete framework core listing. Identify, develop an organizational understanding to manage cybersecurity risk to systems, people, assets, data, and capabilities. The activities in the identify function are foundational for effective use of the framework. Understanding the business context, the resources that support critical functions, and the related cybersecurity risks enables an organization to focus and prioritize its efforts, consistent with its risk management strategy and business needs. Examples of outcome categories within this function include asset management, business environment, governance, risk assessment, and risk management strategy. Protect, develop and implement appropriate safeguards to ensure delivery of critical services. The protect function supports the ability to limit or contain the impact of a potential cybersecurity event. Examples of outcome categories within this function include identity management and access control, awareness and training, data security, information protection processes and procedures, maintenance, and protective technology. Detect, develop and implement appropriate activities to identify the occurrence of a cybersecurity event. The detect function enables timely discovery of cybersecurity events. Examples of outcome categories within this function include anomalies and events, security continuous monitoring, and detection processes. Respond, develop and implement appropriate activities to take action regarding a detected cybersecurity incident. The respond function supports the ability to contain the impact of a potential cybersecurity incident. Examples of outcome categories within this function include response planning, communications, analysis, mitigation, and improvements. Recover, develop and implement appropriate activities to maintain plans for resilience and to restore any capabilities or services that were impaired due to a cybersecurity incident. The recover function supports timely recovery to normal operations to reduce the impact from a cybersecurity incident. Examples of outcome categories within this function include recovery planning, improvements, and communications. Section 2.2. Framework Implementation Tiers. The framework implementation tiers provide context on how an organization views cybersecurity risk and the processes in place to manage that risk. Ranging from partial, Tier 1, to adaptive, Tier 4, tiers describe an increasing degree of rigor and sophistication in cybersecurity risk management practices. They help determine the extent to which cybersecurity risk management is informed by business needs and is integrated into an organization's overall risk management practices. Risk management considerations include many aspects of cybersecurity, including the degree to which privacy and civil liberties considerations are integrated into an organization's management of cybersecurity risk and potential risk responses. The tier selection process considers an organization's current risk management practices, threat environment, legal and regulatory requirements, information sharing practices, business/mission objectives, supply chain cybersecurity requirements, and organizational constraints. Organizations should determine the desired tier, ensuring that the selected level meets the organizational goals, is feasible to implement, and reduces cybersecurity risk to critical assets and resources to levels acceptable to the organization. Organizations should consider leveraging external guidance obtained from federal government departments and agencies, Information Sharing and Analysis Centers, ISACs, Information Sharing and Analysis Organizations, ISAOs, existing maturity models, or other sources to assist in determining their desired tier. While organizations identified as Tier 1, partial, are encouraged to consider moving toward Tier 2 or greater, tiers do not represent maturity levels. Tiers are meant to support organizational decision-making about how to manage cybersecurity risk, as well as which dimensions of the organization are higher priority and could receive additional resources. Progression to higher tiers is encouraged when a cost-benefit analysis indicates a feasible and cost-effective reduction of cybersecurity risk. Successful implementation of the framework is based upon achieving the outcomes described in the organization's target profiles and not upon tier determination. Still, tier selection and designation naturally affect framework profiles. The tier recommendation by business/process level managers, as approved by the senior executive level, will help set the overall tone for how cybersecurity risk will be managed within the organization, and should influence prioritization within a target profile and assessments of progress in addressing gaps. The tier definitions are as follows. Tier 1, partial. Tier 2, risk-informed. Tier 3, repeatable. Tier 4, adaptive. The tiers in more detail. Tier 1, partial. Risk management process. Organizational cybersecurity risk management practices are not formalized, and risk is managed in an ad hoc and sometimes reactive manner. Prioritization of cybersecurity activities may not be directly informed by organizational risk objectives, the threat environment, or business/mission requirements. Integrated Risk Management Program. There is limited awareness of cybersecurity risk at the organizational level. The organization implements cybersecurity risk management on an irregular, case-by-case basis due to varied experience or information gained from outside sources. The organization may not have processes that enable cybersecurity information to be shared within the organization. External participation. The organization does not understand its role in the larger ecosystem with respect to either its dependencies or dependents. The organization does not collaborate with or receive information, for example, threat intelligence, best practices, technologies, from other entities, for example, buyers, suppliers, dependencies, dependents, ISAOs, researchers, governments, nor does it share information. The organization is generally unaware of the cyber supply chain risks of the products and services it provides and that it uses. Tier 2, risk-informed. Risk management process. Risk management practices are approved by management but may not be established as organizational-wide policy. Prioritization of cybersecurity activities and protection needs is directly informed by organizational risk objectives, the threat environment, or business/mission requirements. Integrated Risk Management Program. There is an awareness of cybersecurity risk at the organizational level, but an organization-wide approach to managing cybersecurity risk has not been established. Cybersecurity information is shared within the organization on an informal basis. Consideration of cybersecurity in organizational objectives and programs may occur at some but not all levels of the organization. Cyber risk assessment of organizational and external assets occurs, but is not typically repeatable or reoccurring. External participation. Generally, the organization understands its role in the larger ecosystem with respect to either its own dependencies or dependents, but not both. The organization collaborates with and receives some information from other entities and generates some of its own information, but may not share information with others. Additionally, the organization is aware of the cyber supply chain risks associated with the products and services it provides and uses, but does not act consistently or formally upon those risks. Tier 3, repeatable. Risk management process. The organization's risk management practices are formally approved and expressed as policy. Organizational cybersecurity practices are regularly updated based on the application of risk management processes to changes in business/mission requirements and a changing threat and technology landscape. Integrated Risk Management Program. There is an organization-wide approach to manage cybersecurity risk. Risk-informed policies, processes, and procedures are defined, implemented as intended, and reviewed. Consistent methods are in place to respond effectively to changes in risk. Personnel possess the knowledge and skills to perform their appointed roles and responsibilities. The organization consistently and accurately monitors cybersecurity risk of organizational assets. Senior cybersecurity and non-cybersecurity executives communicate regularly regarding cybersecurity risk. Senior executives ensure consideration of cybersecurity through all lines of operation in the organization. External participation. The organization understands its role, dependencies, and dependence in the larger ecosystem and may contribute to the community's broader understanding of risks. It collaborates with and receives information from other entities regularly that complements internally generated information, and shares information with other entities. The organization is aware of the cyber supply chain risks associated with the products and services it provides and that it uses. Additionally, it usually acts formally upon those risks, including mechanisms such as written agreements to communicate baseline requirements, governance structures, for example, risk councils, and policy implementation and monitoring. Tier 4, Adaptive Risk Management Process. The organization adapts its cybersecurity practices based on previous and current cybersecurity activities, including lessons learned and predictive indicators. Through a process of continuous improvement incorporating advanced cybersecurity technologies and practices, the organization actively adapts to a changing threat and technology landscape and responds in a timely and effective manner to evolving, sophisticated threats. Integrated Risk Management Program. There is an organization-wide approach to managing cybersecurity risk that uses risk-informed policies, processes, and procedures to address potential cybersecurity events. The relationship between cybersecurity risk and organizational objectives is clearly understood and considered when making decisions. Senior executives monitor cybersecurity risk in the same context as financial risk and other organizational risks. The organizational budget is based on an understanding of the current and predicted risk environment and risk tolerance. Business units implement executive vision and analyze system-level risks in the context of the organizational risk tolerances. Cybersecurity risk management is part of the organizational culture and evolves from an awareness of previous activities and continuous awareness of activities on their systems and networks. The organization can quickly and efficiently account for changes to business/mission objectives in how risk is approached and communicated. External participation. The organization understands its role, dependencies, and dependence in the larger ecosystem and contributes to the community's broader understanding of risks. It receives, generates, and reviews prioritized information that informs continuous analysis of its risks as the threat and technology landscapes evolve. The organization shares that information internally and externally with other collaborators. The organization uses real-time or near real-time information to understand and consistently act upon cyber supply chain risks associated with the products and services it provides and that it uses. Additionally, it communicates proactively, using formal, for example agreements, and informal mechanisms to develop and maintain strong supply chain relationships. Section 2.3. Framework Profile. The framework profile is the alignment of the functions, categories, and subcategories with the business requirements, risk tolerance, and resources of the organization. A profile enables organizations to establish a roadmap for reducing cybersecurity risk that is well aligned with organizational and sector goals, considers legal/regulatory requirements and industry best practices, and reflects risk management priorities. Given the complexity of many organizations, they may choose to have multiple profiles, aligned with particular components and recognizing their individual needs. Framework profiles can be used to describe the current state or the desired target state of specific cybersecurity activities. The current profile indicates the cybersecurity outcomes that are currently being achieved. The target profile indicates the outcomes needed to achieve the desired cybersecurity risk management goals. Profiles support business/mission requirements and aid in communicating risk within and between organizations. This framework does not prescribe profile templates, allowing for flexibility in implementation. Comparison of profiles, for example, the current profile and target profile, may reveal gaps to be addressed to meet cybersecurity risk management objectives. An action plan to address these gaps to fulfill a given category or subcategory can contribute to the roadmap described above. Prioritizing the mitigation of gaps is driven by the organization's business needs and risk management processes. This risk-based approach enables an organization to gauge the resources needed, for example, staffing, funding, to achieve cybersecurity goals in a cost-effective, prioritized manner. Furthermore, the framework is a risk-based approach where the applicability and fulfillment of a given subcategory is subject to the profile's scope. Section 2.4. Coordination of framework implementation. A common flow of information and decisions at the following levels within an organization. Executive. Business/process. Implementation/operations. The executive level communicates the mission priorities, available resources, and overall risk tolerance to the business/process level. The business/process level uses the information as inputs into the risk management process, and then collaborates with the implementation/operations level to communicate business needs and create a profile. The implementation/operations level communicates the profile implementation progress to the business/process level. The business/process level uses this information to perform an impact assessment. Business/process level management reports the outcomes of that impact assessment to the executive level to inform the organization's overall risk management process and to the implementation/operations level for awareness of business impact. Figure 2, Notional information and decision flows within an organization. Section 3.0. How to use the framework. An organization can use the framework as a key part of its systematic process for identifying, assessing, and managing cybersecurity risk. The framework is not designed to replace existing processes. An organization can use its current process and overlay it onto the framework to determine gaps in its current cybersecurity risk approach and develop a roadmap to improvement. Using the framework as a cybersecurity risk management tool, an organization can determine activities that are most important to critical service delivery and prioritize expenditures to maximize the impact of the investment. The framework is designed to complement existing business and cybersecurity operations. It can serve as the foundation for a new cybersecurity program or a mechanism for improving an existing program. The framework provides a means of expressing cybersecurity requirements to business partners and customers and can help identify gaps in an organization's cybersecurity practices. It also provides a general set of considerations and processes for considering privacy and civil liberties implications in the context of a cybersecurity program. The framework can be applied throughout the life cycle phases of plan, design, build/buy, deploy, operate, and decommission. The plan phase begins the cycle of any system and lays the groundwork for everything that follows. Overarching cybersecurity considerations should be declared and described as clearly as possible. The plan should recognize that those considerations and requirements are likely to evolve during the remainder of the life cycle. The design phase should account for cybersecurity requirements as a part of a larger multidisciplinary systems engineering process. A key milestone of the design phase is validation that the system's cybersecurity specifications match the needs and risk disposition of the organization as captured in a framework profile. The desired cybersecurity outcomes prioritized in a target profile should be incorporated when A. Developing the system during the build phase and B. Purchasing or outsourcing the system during the buy phase. That same target profile serves as a list of system cybersecurity features that should be assessed when deploying the system to verify all features are implemented. The cybersecurity outcomes determined by using the framework then should serve as a basis for ongoing operation of the system. This includes occasional reassessment, capturing results in a current profile, to verify that cybersecurity requirements are still fulfilled. Typically, a complex web of dependencies, for example, compensating and common controls, among systems means the outcomes documented in target profiles of related systems should be carefully considered as systems are decommissioned. The following sections present different ways in which organizations can use the framework. Section 3.1. Basic review of cybersecurity practices. The framework can be used to compare an organization's current cybersecurity activities with those outlined in the framework core. Through the creation of a current profile, organizations can examine the extent to which they are achieving the outcomes described in the core categories and subcategories, aligned with the 5 high-level functions: identify, protect, detect, respond, and recover. An organization may find that it is already achieving the desired outcomes, thus managing cybersecurity commensurate with the known risk. Alternatively, an organization may determine that it has opportunities to, or needs to, improve. The organization can use that information to develop an action plan to strengthen existing cybersecurity practices and reduce cybersecurity risk. An organization may also find that it is overinvesting to achieve certain outcomes. The organization can use this information to reprioritize resources. While they do not replace a risk management process, these 5 high-level functions will provide a concise way for senior executives and others to distill the fundamental concepts of cybersecurity risk so that they can assess how identified risks are managed, and how their organization stacks up at a high level against existing cybersecurity standards, guidelines, and practices. The framework can also help an organization answer fundamental questions, including how are we doing? Then they can move in a more informed way to strengthen their cybersecurity practices where and when deemed necessary. Section 3.2. Establishing or improving a cybersecurity program. The following steps illustrate how an organization could use the framework to create a new cybersecurity program or improve an existing program. These steps should be repeated as necessary to continuously improve cybersecurity. Step 1. Prioritize and scope. The organization identifies its business/mission objectives and high-level organizational priorities. With this information, the organization makes strategic decisions regarding cybersecurity implementations and determines the scope of systems and assets that support the selected business line or process. The framework can be adapted to support the different business lines or processes within an organization, which may have different business needs and associated risk tolerance. Risk tolerances may be reflected in a target implementation tier. Step 2. Orient. Once the scope of the cybersecurity program has been determined for the business line or process, the organization identifies related systems and assets, regulatory requirements, and overall risk approach. The organization then consults sources to identify threats and vulnerabilities applicable to those systems and assets. Step 3. Create a current profile. The organization develops a current profile by indicating which category and subcategory outcomes from the framework core are currently being achieved. If an outcome is partially achieved, noting this fact will help support subsequent steps by providing baseline information. Step 4. Conduct a risk assessment. This assessment could be guided by the organization's overall risk management process or previous risk assessment activities. The organization analyzes the operational environment in order to discern the likelihood of a cybersecurity event and the impact that the event could have on the organization. It is important that organizations identify emerging risks and use cyber threat information from internal and external sources to gain a better understanding of the likelihood and impact of cybersecurity events. Step 5. Create a target profile. The organization creates a target profile that focuses on the assessment of the framework categories and subcategories describing the organization's desired cybersecurity outcomes. Organizations also may develop their own additional categories and subcategories to account for unique organizational risks. The organization may also consider influences and requirements of external stakeholders such as sector entities, customers, and business partners when creating a target profile. The target profile should appropriately reflect criteria within the target implementation tier. Step 6. Determine, analyze, and prioritize gaps. The organization compares the current profile and the target profile to determine gaps. Next, it creates a prioritized action plan to address gaps, reflecting mission drivers, costs and benefits, and risks, to achieve the outcomes in the target profile. The organization then determines resources, including funding and workforce, necessary to address the gaps. Using profiles in this manner encourages the organization to make informed decisions about cybersecurity activities, supports risk management, and enables the organization to perform cost-effective, targeted improvements. Step 7. Implement action plan. The organization determines which actions to take to address the gaps, if any, identified in the previous step and then adjusts its current cybersecurity practices in order to achieve the target profile. For further guidance, the framework identifies example informative references regarding the categories and subcategories, but organizations should determine which standards, guidelines, and practices, including those that are sector-specific, work best for their needs. An organization repeats the steps as needed to continuously assess and improve its cybersecurity. For instance, organizations may find that more frequent repetition of the orient step improves the quality of risk assessments. Furthermore, organizations may monitor progress through iterative updates to the current profile, subsequently comparing the current profile to the target profile. Organizations may also use this process to align their cybersecurity program with their desired framework implementation tier. Section 3.3. Communicating cybersecurity requirements with stakeholders. The framework provides a common language to communicate requirements among interdependent stakeholders responsible for the delivery of essential critical infrastructure products and services. Examples include: an organization may use a target profile to express cybersecurity risk management requirements to an external service provider, for example, a cloud provider to which it is exporting data. An organization may express its cybersecurity state through a current profile to report results or to compare with acquisition requirements. A critical infrastructure owner/operator, having identified an external partner on whom that infrastructure depends, may use a target profile to convey required categories and subcategories. A critical infrastructure sector may establish a target profile that can be used among its constituents as an initial baseline profile to build their tailored target profiles. An organization can better manage cybersecurity risk among stakeholders by assessing their position in the critical infrastructure and the broader digital economy using implementation tiers. Communication is especially important among stakeholders up and down supply chains. Supply chains are complex, globally distributed, and interconnected sets of resources and processes between multiple levels of organizations. Supply chains begin with the sourcing of products and services and extend from the design, development, manufacturing, processing, handling, and delivery of products and services to the end user. Given these complex and interconnected relationships, supply chain risk management, SCRM, is a critical organizational function. Cyber SCRM is the set of activities necessary to manage cybersecurity risk associated with external parties. More specifically, Cyber SCRM addresses both the cybersecurity effect an organization has on external parties and the cybersecurity effect external parties have on an organization. A primary objective of Cyber SCRM is to identify, assess, and mitigate products and services that may contain potentially malicious functionality, are counterfeit, or are vulnerable due to poor manufacturing and development practices within the cyber supply chain. 12. Cyber SCRM activities may include determining cybersecurity requirements for suppliers, enacting cybersecurity requirements through formal agreement, for example, contracts, communicating to suppliers how those cybersecurity requirements will be verified and validated, verifying that cybersecurity requirements are met through a variety of assessment methodologies, and governing and managing the above activities. A Cyber SCRM encompasses technology suppliers and buyers, as well as non-technology suppliers and buyers, where technology is minimally composed of information technology, IT, industrial control systems, ICS, cyber physical systems, CPS, and connected devices more generally, including the Internet of Things, IoT. Figure 3 depicts an organization at a single point in time. However, through the normal course of business operations, most organizations will be both an upstream supplier and downstream buyer in relation to other organizations or end users. Some parties can comprise an organization's cybersecurity ecosystem. These relationships highlight the crucial role of Cyber SCRM in addressing cybersecurity risk in critical infrastructure and the broader digital economy. These relationships, the products and services they provide, and the risks they present should be identified and factored into the protective and detective capabilities of organizations, as well as their response and recovery protocols. In the figure above, buyer refers to the downstream people or organizations that consume a given product or service from an organization, including both for-profit and not-for-profit organizations. Supplier encompasses upstream product and service providers that are used for an organization's internal purposes, for example, IT infrastructure, or integrated into the products or services provided to the buyer. These terms are applicable for both technology-based and non-technology-based products and services. Whether considering individual subcategories of the core or the comprehensive considerations of a profile, the framework offers organizations and their partners a method to help ensure the new product or service meets critical security outcomes. By first selecting outcomes that are relevant to the context, for example, transmission of personally identifiable information, PII, mission-critical service delivery, data verification services, product or service integrity, the organization then can evaluate partners against those criteria. For example, if a system is being purchased that will monitor operational technology, OT, for anomalous network communication, availability may be a particularly important cybersecurity objective to achieve and should drive a technology supplier evaluation against applicable. Section 3.4. Buying decisions. Since a framework target profile is a prioritized list of organizational cybersecurity requirements, target profiles can be used to inform decisions about buying products and services. This transaction varies from communicating cybersecurity requirements with stakeholders, addressed in Section 3.3, in that it may not be possible to impose a set of cybersecurity requirements on the supplier. The objective should be to make the best buying decision among multiple suppliers, given a carefully determined list of cybersecurity requirements. Often, this means some degree of trade-off, comparing multiple products or services with known gaps to the target profile. Once a product or service is purchased, the profile also can be used to track and address residual cybersecurity risk. For example, if the service or product purchased did not meet all the objectives described in the target profile, the organization can address the residual risk through other management actions. The profile also provides the organization a method for assessing if the product meets cybersecurity outcomes through periodic review and testing mechanisms. Section 3.5. Identifying opportunities for new or revised informative references. The framework can be used to identify opportunities for new or revised standards, guidelines, or practices where additional informative references would help organizations address emerging needs. An organization implementing a given subcategory, or developing a new subcategory, might discover that there are few informative references, if any, for a related activity. To address that need, the organization might collaborate with technology leaders and/or standards bodies to draft, develop, and coordinate standards, guidelines, or practices. Section 3.6. Methodology to protect privacy and civil liberties. This section describes a methodology to address individual privacy and civil liberties implications that may result from cybersecurity. This methodology is intended to be a general set of considerations and processes since privacy and civil liberties implications may differ by sector or over time, and organizations may address these considerations and processes with a range of technical implementations. Nonetheless, not all activities in a cybersecurity program engender privacy and civil liberties considerations. Technical privacy standards, guidelines, and additional best practices may need to be developed to support improved technical implementations. Privacy and cybersecurity have a strong connection. An organization's cybersecurity activities also can create risks to privacy and civil liberties when personal information is used, collected, processed, maintained, or disclosed. Some examples include cybersecurity activities that result in the over-collection or over-retention of personal information, disclosure or use of personal information unrelated to cybersecurity activities, and cybersecurity mitigation activities that result in denial of service or other similar potentially adverse impacts, including some types of incident detection or monitoring that may inhibit freedom of expression or association. The government and its agents have a responsibility to protect civil liberties arising from cybersecurity activities. As referenced in the methodology below, government or its agents that own or operate critical infrastructure should have a process in place to support compliance of cybersecurity activities with applicable privacy laws, regulations, and constitutional requirements. To address privacy implications, organizations may consider how their cybersecurity program might incorporate privacy principles such as data minimization in the collection, disclosure, and retention of personal information material related to the cybersecurity incident. Use limitations outside of cybersecurity activities on any information collected specifically for cybersecurity activities, transparency for certain cybersecurity activities, individual consent and redress for adverse impacts arising from use of personal information in cybersecurity activities, data quality, integrity, and security, and accountability and auditing. As organizations assess the framework core in Appendix A, the following processes and activities may be considered as a means to address the above-referenced privacy and civil liberties implications. Governance of cybersecurity risk. An organization's assessment of cybersecurity risk and potential risk responses considers the privacy implications of its cybersecurity program. Individuals with cybersecurity-related privacy responsibilities report to appropriate management and are appropriately trained. Process is in place to support compliance of cybersecurity activities with applicable privacy laws, regulations, and constitutional requirements. Process is in place to assess implementation of the above organizational measures and controls. Approaches to identifying, authenticating, and authorizing individuals to access organizational assets and systems. Steps are taken to identify and address the privacy implications of identity management and access control measures to the extent that they involve collection, disclosure, or use of personal information. Awareness and training measures. Applicable information from organizational privacy policies is included in cybersecurity workforce training and awareness activities. Service providers that provide cybersecurity-related services for the organization are informed about the organization's applicable privacy policies. Anomalous activity detection and system and assets monitoring. Process is in place to conduct a privacy review of an organization's anomalous activity detection and cybersecurity monitoring. Response activities, including information sharing or other mitigation efforts. Process is in place to assess and address whether, when, how, and the extent to which personal information is shared outside the organization as part of cybersecurity information sharing activities. Process is in place to conduct a privacy review of an organization's cybersecurity mitigation efforts. Section 4.0. Self-assessing cybersecurity risk with the framework. The cybersecurity framework is designed to reduce risk by improving the management of cybersecurity risk to organizational objectives. Ideally, organizations using the framework will be able to measure and assign values to their risk along with the cost and benefits of steps taken to reduce risk to acceptable levels. The better an organization is able to measure its risk, costs, and benefits of cybersecurity strategies and steps, the more rational, effective, and valuable its cybersecurity approach and investments will be. Over time, self-assessment and measurement should improve decision-making about investment priorities. For example, measuring, or at least robustly characterizing, aspects of an organization's cybersecurity state and trends over time can enable that organization to understand and convey meaningful risk information to dependents, suppliers, buyers, and other parties. An organization can accomplish this internally or by seeking a third-party assessment. If done properly and with an appreciation of limitations, these measurements can provide a basis for strong trusted relationships, both inside and outside of an organization. To examine the effectiveness of investments, an organization must first have a clear understanding of its organizational objectives, the relationship between those objectives and supportive cybersecurity outcomes, and how those discrete cybersecurity outcomes are implemented and managed. While measurements of all those items is beyond the scope of the framework, the cybersecurity outcomes of the framework core support self-assessment of investment effectiveness and cybersecurity activities in the following ways. Making choices about how different portions of the cybersecurity operation should influence the selection of target implementation tiers. Evaluating the organization's approach to cybersecurity risk management by determining current implementation tiers. Prioritizing cybersecurity outcomes by developing target profiles. Determining the degree to which specific cybersecurity steps achieve desired cybersecurity outcomes by assessing current profiles. Measuring the degree of implementation for controls catalogs or technical guidance listed as informative references. The development of cybersecurity performance metrics is evolving. Organizations should be thoughtful, creative, and careful about the ways in which they employ measurements to optimize use, while avoiding reliance on artificial indicators of current state and progress in improving cybersecurity risk management. Judging cyber risk requires discipline and should be revisited periodically. Anytime measurements are employed as part of the framework process, organizations are encouraged to clearly identify and know why these measurements are important and how they will contribute to the overall management of cybersecurity risk. They also should be clear about the limitations of measurements that are used. For example, tracking security measures and business outcomes may provide meaningful insight as to how changes in granular security controls affect the completion of organizational objectives. Verifying achievement of some organizational objectives requires analyzing the data only after that objective was to have been achieved. This type of lagging measure is more absolute. However, it is often more valuable to predict whether a cybersecurity risk may occur, and the impact it might have, using a leading measure. Organizations are encouraged to innovate and customize how they incorporate measurements into their application of the framework with a full appreciation of their usefulness and limitations. This concludes the audiobook. Please like and subscribe for more content.